Hey, here we are. Should have a compiler ready to go. If you watched the video first on setting up your compiler, you should have a compiler ready to run. Go to Visual Studio, fire that up. When we're done going through these slides, it'll go really quick. We're just to explain variables and data types and some of the things that they are in C++. It kind of transfers to other languages, but it's really important to get started with variables and data types because, well, you need to have things inside of your program. So you need to have data and different data types to manipulate and to build objects with. So we have to have a place to store them. We have to be able to declare them. We have to be able to use them. And to do that, before we can use any of these, we have to know what our variables and data types are. So let's go through that really quick. All right. We'll explore the fundamental concepts of data types and variables in C++. And there's also rules to declaring a variable. And we'll talk about this almost every single slide. And this is our declaration of a variable. And this is an initialized variable that's going to get assigned value. When you assign a variable in C++, you have to tell it what data type it is. So you have to say, what's your data type first? This is an integer. We'll talk about that next. You give it a name. The assignment operator is a single equal sign, okay? And that means it's going to assign value to. And the value we're going to give whole number is an integer because we declared it to be an integer. And you always end your statements with a semicolon. Okay, so this is the rules of declaring a variable and initializing it at the same time. We're going to give it a data type, and we'll look at all the different data types that we can give it. We give it a variable name. Then we assign it value with an assignment operator. That's a single equal sign. We're going to learn about a single equal sign and a double equal sign and a double equal sign in conditionals. And that's going to be the comparison operator. But here, we're just going to assign the value using equal sign. So here we go. Let's talk about variables and data types in C++. What are data types? Well, they define the type of data that a variable can hold. So we have to tell C++, hey, you're going to hold on to integers, and the variable name's like, okay, I'll hold on to integers, and you say you're going to hold on to a double, and another variable name says, look at me, I'm holding on to doubles. So we are going to tell different types of data that we can have. So let's look at the different types of data that I have here and what they represent. Right here we have an integer. And everybody's so smart, we got through 5th grade math. An integer is a whole number, okay? It's a whole number, positive or negative, all right? So it's a positive or negative whole number. A float is considered a floating point number. And the reason it's a floating point number is because this decimal. So a float is a floating point number. How do we move a decimal? Well, we make it float back and forth. And what do? These are 10 base. We're in 10 base, right? This is the 10 base, ones, tens, hundreds, 10 base. Even the decimal places are 10 base. So all we need to do is multiply or divide by 10. And whenever we multiply or divide by 10, the decimal will float either direction. A double is a larger float. So when we get to the double slide, we'll talk about a larger float. So a double is also a decimal number, but it's just a larger one than a float. A character or char is a single character. Notice a char is going to have single quotes. Okay? So that is a char is a single character. So we can manipulate things by their single characters. A boolean or a bool is only true or false, 1 or 0. Okay? These are just data types. We're going to talk about each one of them in their own slide. A string, notice that these is a lot of characters. Whenever we spell a word, we use characters, right? And a word is just an assembly of characters in certain order. So all a string is just a collection of characters. And notice there's 2 quotes around a string. So a string is a collection of characters, or what we like to call a constant char array. And we'll get to that. I'm going to throw this in, and we're going to talk more about pointers later because it's C++. But this is a variable. A pointer, see that star, that asterisk there? That declares this is an integer pointer. And what that holds, if you look at a integer holds 100. A pointer holds the memory address. So we can actually access the memory address. And this gives us really good use to pass by reference and pass by value when we get into functions. But the pointer is just a variable. So we're going to talk about data types in that aspect. All right, fun. We're almost done. All right, let's go through these. We talked about integer already. It's a whole number. That's it. Negative 10, whole number, positive or negative, right? Up to 4 bytes. And there's different ones we can use, okay? We have variations of integer sizes, short, long, and long, long. Right now, if you first dip into C++, you will get to these later in your programming career. But right now, just remember, an integer is the whole number. How do we declare an integer? Man, what's the rules? Data type, name, assignment operator, value, and semicolon. Okay, so that's an integer, one of our data types. A floating point, as we talked about that earlier, a floating point is used for single precision floating point numbers. So a float is not as big as a double. So a float goes to, I think, 8 points of precision, and a double goes to 16 points of precision. And all we're going to do to declare this, remember, data type, name, assignment operator, and value. Notice that it's 3.14. So now we have a double. Double is more than sufficient than what you're going to need for anything you do in this first course, I'm pretty sure. Okay, so you could use float. It's not as accurate. Again, it's not as big. And a double can hold more numbers. So it's much more precise. And double is going to be most sufficient. Now, if you did declare a float, guess what you would do? You would replace double with float. Simple, right? Program is easy. So far, yes. A char is character data type. Now, anything on single quotes that's on your keyboard can be a character, as long as it's a single character, right? So that's a char or a character. Okay, it holds single things. 5 can be a char because all it does is evaluate to the ASCII table. And the ASCII table is everything on your keyboard that has an association with 10-base, binary, octal, and hexadecimal. So when you start typing on your keyboard, those single letters get turned into machine code so that your processor or your programs can read them. So we have chars, anything with single quotes. When we declare a char, what do? What is the data type we're making? We're making a char data type. What is the name of it? CH. We're going to assign it what? We're going to assign it A. That's a bad variable name. It should be A. I think we fix that later. But same rules. But we have to make sure it was easy. Integer equals 10, right? Integer whole num will be assigned 10 semicolon. Here we say char is going to be assigned a char, but we have to give it the correct data type, and that means single quotes. Single quotes on chars. Bool is a 1 or a 0. Okay? It's a truth or false. A bool is a truthy. Okay? So you can declare bools. You can say, okay, and when we do that, it's really cool to do that. And the better you get with the bool declarations when you're like a game developer or something like that, they're just great flags, right? You have these if statements, these conditionals that control the flow of our program, and they only work if it's true. So you can turn things on and off. It's like switches. So anybody's going into electrical engineering, these are your switches. Right, so these are really, really important, and you can assign them. Bool is true, and when we get into looping structures, we use them all the time. When we do conditionals, we use them all the time. But it's cool because it's a data type. So this data type is a bool. So there is a data type, and it's very small. We'll look at that when we look at how much memory it allocates, but it doesn't hold on to a lot, so you can do a whole bunch with bools. I like the bool. Strings. Okay, string is a data type. It's a collection of characters. So really, it's a constant char array. So what we talked about. L is a character all by itself, right? If I had single quote or double quotes L, that would be a string, right? Because it's double quotes. But a single quote is just going to be a character. Well, how do we build words? We build words with a collection of characters. So a string is a collection of characters. So what we can do is we can say data type is string. The variable is name. It's going to be assigned the value of, double quotes, Leo the dog, semicolon. So now Leo the dog is stored inside a name, and that is 3, 6, 9, 11 spaces stored in 11 characters, because the spaces are also characters. 11 spaces stored inside of the variable called name. Isn't that great? So that's pretty cool. Anytime we need name, we can just print out name, see out name, and it'll give us Leo the dog. So that's what a string is. A string is just an immutable character array. And when I say immutable, it just means that we can't change the string. We can manipulate it, but when we make it, it doesn't change because it's a constant array. We'll learn more about constant array. Just right now, know a string is awesome, and you can do so much with strings. They're so much fun. You get to print whole things out because they're strings. You can manipulate things because they're strings. You do all this really cool things because of strings, and strings are really important. So bools and strings, I guess, are my two favorite. And pointer is my very favorite, but just we're going to play with pointers when we get to arrays and collections. But right now, I'm just going to say a pointer is a variable, because in my experience in teaching C++, people get so freaked out about pointers. Oh, it's just a variable. If you can declare integer x equals 10, you can say integer pointer y equals the address of x. It's just a variable. It holds on to something. What does a variable do? It holds on to a data type. So what is a pointer? It's a variable that holds on to a data type. An integer holds on to an integer. An integer pointer holds on to the memory address of an integer. Okay? More on that later. We'll look at this when we do a little bit of coding. But I declared an integer called whole number. I did that earlier. Now I declared my my integer pointer. See that integer pointer? Depends on who your instructor is. They might have the star over here, but you'll figure it out. I usually put my star over on the variable name. And that's going to equal, and then this is called the address of, because, well, integer has to hold an integer, so an integer pointer has to hold the memory address. So we're just going to take the whole number and address. And then when we print it out, cout is how we print out, and we talked about that with hello world, right? Character out. We're just going to take the memory address, and what's the memory address of the whole number when it was initialized and allocated? Well, this was the memory address. That's what my compiler said it was. So that's what I put. So a pointer is just a variable. So don't let it freak you out. They're just a variable. A constant means it can't be changed. So if I'm writing an application that has to deal with money, I'm going to make my money constants. Right? A constant double dime. That's a little overkill for a dime. I could use a float. But a constant, let's say, because I don't want, a dime's 10 cents, period. You don't have a dime that's not 10 cents. A quarter is 25 cents. This way, you wouldn't have anybody change it. It's not volatile. You can't have somebody go in and say, oh, I'm just going to say I want 10 dimes. And then they go into the code and they change a dime instead of equal 0.10. They make it equal a million. And then they have $10 million. And that's not good for the bank. So if you're writing for the bank, make sure all your money is constant. And that just means it can't be changed, right? It's the same thing as declaring a variable, right? Type, name, assignment, value, semicolon. All we're saying is don't change it. That's it. Keep. You can't mess with my data. Side effects. Variable declaration and initialization. We did it all in one line because C++ likes that. The compiler likes when you've declared a variable, you have it initialized, but you don't have to. If you declare your variable and don't initialize or store anything in it, if you try to use it and it hasn't been given value, you will get a syntax error and your program won't run. So here you can declare just plain old declaration of age, okay? And then later in your program, if you don't forget, you can declare age 25 or initialize it. So you declare it, it builds it in memory, and then you initialize it by giving it value. To me, you can do these, and there are some people that will just declare variables, and then they're really smart and don't forget to initialize them later. But I'm not one of those people. I'll always try and run my things without having all my things initialized, and then I have to go back. So just a bad habit from old programming languages. Okay, so that's variable declaration and initialization. We talked about that earlier. So let's go. We're almost done with our stuff. We want to talk about the scope of variables. Now, the scope. Let's say you're an astrologer because the eclipse is coming up, and you have a telescope. Or you're a pirate and you have the telescope there. What does that mean? That means you can only see what the telescope allows you to see, right? That's in scope. So scope defines the visibility and lifetime of variables because our variables have specific visibility. Lifetime's a little, we'll talk about lifetime later, but visibility. So sometimes when we declare a variable in one thing's called a function or a method, if it's declared in that function or method and we try and access it from outside that method, that means that we can't see it. It doesn't have scope. So if you make your variables global, then you can see it no matter what, and that's not safe. That's not good programming. There are times you need to, but not really. And if you make it local, meaning it just belongs to the method that's initialized in, or let's say you make it accessible in a class. Let's say we build a class and we have instance variables. When we can make those, we can stretch those and give them permissions left and right, public, private, and protected. So just know that we'll talk about the scope of variables when we get into methods. And it's just, since we're on variables, you might as well say scope. All right. Another thing we can do with a variable is called typecasting. It lets us convert one data into another. Now, if I'm doing division using integers, if I only declare integers, what happens when I take, like 3 into 10? Well, the only thing that it's going to give me, if I take 3 into 10, integer division says 3, and that's 9, and then remember you get 1, and you're going to get 3.33. But if these are both integers, 3 and 10, then I'm only going to see a 3. Because it only shows the integer, right? It truncates everything else. You can't see it because it's not a double. If I divided 3 into 10 and it was a double, it would give me the value. So you can cast into a double. Here's another example where I took my char, and it's A, and I wanted the ASCII value of it. So what did I do? I took A, which is, of course, a character. It's a completely different data type, right? But it can evaluate to an integer. So we're just going to cast it through this integer method. And then, of course, it'll come out. Capital A on the ASCII table is 65. So that's typecasting. We'll get to that later. But you should know it. All right, so those are the details of it. So what we're going to do is I'm going to bounce over to my compiler of Visual Studio. And we're going to talk through a couple of little pieces of code that I wrote. And then we'll be done with the introduction to variables and data types. And when we get back, then we can start manipulating data types using conditional statements and loops. And then we move on. So that's this. We'll get back to the next one in 1 minute. Hey, okay, we're back. And I just went ahead and typed this stuff in. We talked earlier about using namespace std so that we don't have to do a bunch of scope resolution operators. You can if you want to. Again, that's going to be up to your instructor and how they want you to use their namespace. But I usually throw it up using namespace standard. It speeds up some of my snippets of code. Here, let's just look at this stuff really quick. Remember, data type, name, assigned, value. So what we did was we just took the stuff we had inside of our PowerPoint, and then we're just going to print them out. We're going to print out the variable, and it's going to give us the data. And then this is strings, because why? It's inside of quotes. And then we're going to look at how many bytes of memory each one of us gives it. And we get to use a size of operator. And that's pretty cool. The size of operator is pretty neat. Let you see the size of memory allocated for each one of your data types. So we'll go ahead and run this really quick. And you could pause the video and type these things in if you want to. Get used to typing Please, I've had so many programmers that start and they're like, I don't like to type. I'm like, well, this is too bad. You're a writer now. You need to type. Okay, so again, 100, whole number, right? Printed out whole number is equal to whole num. 100 is equal to whole num. It's given 4 bytes of memory. This is our float, small decimal. It's also given 4 bytes of memory. 75 point, that's our double. That's given 8 bytes of memory. Our character, A, is given 1 byte of memory. Our bool is going to print out 1 because it's true. If we set our bool to false, it would print out 0. And that is given 1 byte of memory. So again, that's not a lot of space. So you can do a lot with bools and a lot with chars. Leo the dog is given 40 bytes of memory because it counts how big it is as a char array, and then it assigns that in a continuous block of memory. So Leo the dog gets 40 bytes of memory. Our pointer, memory location, is given 8 bytes of memory. Now, the pointer is cool, and it has double the memory of the integer because it's an integer pointer because it's kind of combining 2 different variable types. So that's pretty cool. So if we have that, that's what we're going to evaluate too. There's a memory location for Visual Studio. Remember, when you start Visual Studio and you give your program a name and it comes up with the hello world thing inside the main, make sure your Solution Explorer is up. It's going to be so much easier, I promise you. All right, let's call it for this, and we'll start a new one, and let's start building the program. Let's start coding. Now that you know how to declare a variable, let's start being able to letting our program make decisions for us. So we'll do a little more coding because we have to talk about conditional statements and we have to talk about loops. Okay, until then, bye.